During the last decade, we have begun to see the rise of virtual reality, or VR, in the video gaming industry. While VR was introduced to most people through gaming, many believe that VR will continue to revolutionize how we interact with the digital world. We can already see prototypes of how VR technologies can be used in medicine, engineering, and even academic research, but many of these prototypes are still works in progress. My thesis argues that in order for users to be productive using VR technologies, they will need the ability to annotate the world around them. Grounded in the field of human-computer interaction, my research explores my original design for a multimedia annotation system that allows users to effectively annotate the world around them and also view these annotations later with perspective context. There are two major types of annotations in my system. First, Doodle annotations, and second, audio annotations. For Doodle annotations, the user first selects a point of interest. A clear plane appears between the user and the point of interest, and this clear plane represents the annotation space that the user can draw on. Once done, the user saves the annotation, and an image doodle and perspective of the user is captured. For audio annotations, users select a point of interest and begin a recording. During an audio annotation, voice audio is recorded, as well as the positions and orientations of the player's head and two controllers. My annotation system is designed around the concept of preserving as much about the annotator's context and perspective in the annotation itself, and presenting this information while viewing the annotation later. In Doodle annotations, this is done by capturing the annotator's point of view and saving that as the background of the doodle, as well as keeping track of the annotator's position and orientation to teleport back to while viewing the annotation at a later time. In audio annotations, perspective preservation is done by recording the positions and orientations of the annotator's head and controller anchors, and using an avatar during playback to show this additional information about the annotator's perspective. While my work is still in the early prototype phases, I am working with professors at Dartmouth who might use my VR annotation system in their own research to better inform my design decisions and process. Their specific user needs have been extraordinarily helpful as I develop my design for an annotation system.